The problem statement in question 2 says that suppose you are given a circle, give a construction to find its center. So given any circle, we have to figure out the exact location of the center. We have to do a construction to locate the center. So I'm going to show you a simulation to help you understand how to do this construction. So here's a simulation which shows a circle. The center is not shown. We have to do a construction to locate the exact position of the center. Now the result that we're going to use to solve this problem, to figure out the construction, is that if you take any chord of the circle and if you draw its perpendicular bisector, then that perpendicular bisector will pass through the center of the circle, because the center is equidistant from all points on the circle. Okay, so let's take any 2 points on the circle. So here I've taken a point A and I've taken another point B. So let's and these points, the locations of these points can be anywhere on the circle. Now let's join these 2 points. So we get this chord AB, and now let's draw the perpendicular bisector of AB. So this is the perpendicular bisector of AB. We know how to construct a perpendicular bisector using ruler and compass, so we can do that easily. So what we know so far is that the center of the circle must lie on this perpendicular bisector, because every point on this perpendicular bisector is equidistant at the same distance from A and B. And because the center must be at the same distance from A and B, it must also lie on this perpendicular bisector. But there are infinitely many points on this perpendicular bisector. So how do we locate the center? Now for that we'll have to take another point. So let's take another point C anywhere on the circle, and now let's make another chord. So let's join, for example, the points B and C and so we get the chord BC. Now if we draw the perpendicular bisector of BC as well, like this, we know that the center will also lie on this second perpendicular bisector, because the center is also equidistant from B and C. So the center lies on both the perpendicular bisectors. It lies on the first perpendicular bisector and it also lies on the second perpendicular bisector, and this means that it must lie on their point of intersection, and which is basically unique. So the construction is as follows: take one chord, take any chord, draw its perpendicular bisector, take another chord, draw its perpendicular bisector, and the point of intersection is your center. And it doesn't matter how you take the chords. No matter how you take the chords, you can see that the 2 perpendicular bisectors will always intersect at the center of the circle. So this is the required construction. To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.